One of the trickiest things about TypeScript is dealing with enums. Let me show you what I mean. Let's take this React app for an example. Here we have a list of blog posts. Each blog post has a list of tags and they can be filtered. For example, if you just want to see React and Next.js related blogs, you can filter them like this. And if you click, you land here on my blog. Now this is a simple example, but it really demonstrates the difficulties of working with enums in TypeScript. Let's take a look at the code. Here we have our definitions. A blog post has a list of tags, as you can see. And here we define tags using the normal enum keyword. Having these definitions means we can easily define a list of blog posts. Here, as you can see, for example, the first entry has React and Next.js. First of all, let's talk about the filters. Here we want to have a list of all the available filters. Now you might think this is a simple task, but it's actually pretty tricky. Now in TypeScript, there is no method to get the list of all the enum values, which means we have to write this kind of code. Basically take all the keys of the tag enum, and then we filter out the items that are not numbers. You may be wondering why we're doing this. Let's take a look at the keys of the tag. As you can see, we have the numbers and the strings. So we have to basically filter out the numbers. That's the first problem. The second problem is when rendering the tags. In order to figure out if a tag button is active or not, we have to convert from string to enum. And for that, you have to use this weird syntax. Here we use the as keyword, and this is considered not so safe actually. And the same problem we have here on the callback function, where we have to transform a string to an enum. Now there are two other problems I want to highlight here. The first one is the serializability. Let's take, for example, our blog posts and console log them. As you can see here, the tags are actually just numbers under the hood, and that is a big problem. For example, if you want to get the data from an API, the API will never return 1 for Git and 2 for React or something like that. So that is the first problem. Now, the second problem is the lack of duck typing. And if you don't know what duck typing means, it's basically a language feature where you don't have to use the same instance of the type. For example, if we go here, we have our post type. Let's go to our post component. This is the component that is used to display every card. And as you can see, the props are defined as post and using the direct type. Now, this means that we have a tight coupling here. Another approach would be to define the props independently. Although we have the same types, you can see that TypeScript really cannot mix two types of enums. So the second approach would be to using string enums. So this is basically an extension of enums. Now, if you look at the syntax, it's very similar to before, but here we can actually assign values. Now, this does fix a few problems. One of them is the tags values. You don't have to filter out the numbers. And the second one is the serializability. So if you console log the posts, let's take a look. As you can see here, we have strings and not numbers. So that's better. But still we have the same problem as before with the tight coupling. Now if we define our own types for the component props, you can see that we receive the same problem as before. That tag is not assignable to tag type, although both enums contain the same values. Now let's take a look at the third approach, and this is one of my favorite approaches to dealing with enums with TypeScript, and that is using string literals. And here we define tag as a union of strings. So tag can be either Git or React or Next.js or Node.js. Now this has the advantage that you can use strings directly. You don't have to use tag.react or tag.next.js every time. And it also supports duck typing. So if we come to our postcard component props, as you can see, there is actually no problem using another instance of another type, which is really cool, which means that it doesn't matter where we get our data from, as long as it adheres to this type definition, we can use it here. And here we have real type safety, which means if an element is missing, we will get an error. For example, here you can see Node.js is not assignable because Node.js is not part of the new type. Now this is my favorite approach, but still it has one problem that we need to address, and that is how we get enum values. Now for that you have to define it manually, and there is no method for generating it. Now this approach is very similar to the string literals one, but it uses a very neat trick. Here we start by defining the enum values first, and from that we infer the type. So it's the other way around. And I find this approach just perfect, because here we are sure that we don't miss any value here when the enum is updated, and we have all the advantages of before. We have loose coupling and serializability. I hope this was helpful, and see you in the next one.